All right. Okay. So if we're set there, then if you have any questions about the class or the course policies, let me know. If not, we'll get started with the material. Okay. Again, here's the textbook. Anybody excited? All right. That's what I like to hear. All right. So we've got chapter 1. All right. This is our introduction. So what is statistics? Why do we bother studying statistics? Well, why do we bother studying anything? Okay, I argue that we study classes or whatever it is, whatever subject you are taking. My argument is that we take these classes to help us understand the world around us, okay? So, chemistry, you understand how molecular bonds form and how that causes materials to form and things like that. In statistics, again, we want to understand the world around us, okay? In particular, statistics allows us to draw conclusions from limited data. Are you guys able to read my handwriting? Large enough. Those of you on the back, feel free to move forward. The front seats are always the best ones, okay? All right. Statistics allows us to draw conclusions from limited data. What does that mean? Okay? Okay. Limited data. All right, so what is data, first of all? Okay, data is information. That's right. Okay? And usually, it's information that's been organized and generally has some kind of context, okay? Usually organized, has some kind of context. And in this day and age, we are constantly generating data, okay? If you have a cell phone, and I'm sure every single one of you do, you are generating this stream of data. Everywhere you walk, you probably have these location services turned on. It's telling, the cloud, whoever that might be, where you are, where you're located, where you're going. They're collecting information about your location, other people's location. They can kind of get an idea of who's hanging out with who. Every time you check your email, there's a from and a to. all sorts of information is being generated. Okay, that's just from your cell phone. Okay, there's all, every time you go to the doctor, every time you pay for something with a credit card, all right, all of this information is forming, all right, and that's a newer thing, but data has existed for thousands and thousands of years, of course. All right? And in this class, we're going to learn classical statistics. So a lot of these methods are older methods, but we have to start somewhere, right? Okay, so data is information, but we're dealing in a situation where we have limited data, okay? And what I mean by that is, if we look at the world, let's say we have a question that we want to ask. And we say, what is the average weight of an American? How can we answer that question? What is the average weight of an American? Okay? Well, I hope you guys are familiar with the concept of an average, or taking the mean. You guys have heard that before, right? At least somewhere in like middle school or high school, you have, if you have 10 numbers, to take the average, you add up all 10 numbers and you divide by 10. Okay, so if I had the question, what is the average weight of an American? The only true way to get that answer is to find the weight of every single American, add them all up, all 300-something million, and then divide by 300-something million. Okay, so let's say there's 315,684,000 people, or whatever it is. I would have to take all of those numbers, add them up, and divide by all the people. Okay, and that's how I would get an average. Does that make sense? Okay. That is the only way I can get a true average value. But is there any way I can find out the weight of every single American out there? No, there's no way, okay? Well, first off, it's rude to ask someone their weight. But let's say everybody was willing to give me their weight and were willing to be completely honest. I would not have the time or resources to get a hold of every single person. Okay? So if I wanted to ask the question, what is the average weight of an American? I won't be able to ask all 300-something million people. I will have to ask maybe a few thousand people. But if I take the average of a few thousand people rather than all Americans, will that answer my question of what is the average weight of an American? Some of you are nodding yes, some of you are shaking your head no. Well, this is why we learn statistics. We're hoping that our answer from a few thousand people can apply to the millions of people, and in order for that to happen, we need to understand statistics. Okay, so let me write all that in just a couple sentences. So limited data, all right? So let's say I ask, average American, okay? And well, how do we define American anyway, right? U.S. citizen, person living in the borders of the United States? I don't know. Okay. So to answer, need the weight. Every single all 300 plus. Okay, we do not have the resources to gather all of this data. Instead, we deal with maybe only a few thousand pupils. This concept okay? All right, so if we illustrate this, we have something called the population. The population is everyone we are interested in studying. But the population is too big to directly study. So in our question, what is the average weight of an American? What is our population?
300 million.
Yeah, it's every single American, so all 300 plus million people. Too big to study directly. So instead of studying everyone in the population, we draw from the population a smaller group called a sample. So a sample might have a couple thousand. Okay. So the sample what we will learn in our class, based on what we see in the sample, can provide information about the population. And that step is called inference. You're inferring information about the population based on your sample. Okay. But in order to do that, we have to understand how we should draw a sample, how we should select people, and we have to understand the nature of data. I saw a hand go up here for a question. We changed our mind. Yes?
So it goes to population is samples what we study, and then inference is what we get from that sample.
Yeah, inference is that process of drawing information or drawing conclusions from our limited data. So the limited data means we are studying a sample rather than the actual population. But we want to draw information from that. That's why we draw conclusions. Okay. You know, that's how, you know, all of that information you read. They say something like, what is the average height of a male, American male? Do you guys know?
5'11".
5'10"?
It's about 5'9½". Okay, 5'9½". Average height of an American. How did they get that? Did they ask all, you know, 150 million Americans, males? No. Okay, they asked a few thousand, and they're drawing an inference about average height. So, about 5'9½". Average height for a female?
5'6".
About 5'4". 5'4". Okay, so when we gather data, okay, our most basic tool for organizing data is a table. So imagine you want to know what is the average weight of an American. So you decide to ask a whole bunch of people, how would you gather this data, or how would you organize this data? Okay. Well, maybe we want to ask each person, what's your name? How much do you weigh? Are you male or female? How old are you? Okay. So we will ask many people the following questions. Your name. Okay. So your sex. Your weight. Your age. Okay. And to organize this, we'll have our data table. Okay. Or sometimes we might call it a case table. And we call it a case table because we have information about every single case. And the case being each line in the table would be a case. So if I have the name, sex, weight, and age. Those are the columns, and maybe the first person I ask is Adam. Adam is male, he weighs 165. And is 20 years old. then maybe we asked Betty. Girl, female. 130. 19. And, okay. So in this case, or in our example, what is each case? Each case is,
A description of.
each case is a person, okay? Every single person gets a different line, all right? And so our data table so far has 3 cases and 4 variables. Okay? So each column is a variable. And we have 2 main types of variables. We have categorical variables, and we have numeric or quantitative variables. All right. So, what kind of variable do you think sex is? Categorical. We are putting people into categories. Some people are categorized as male. Some people are categorized as female. Okay. Maybe it's not as simple as that, but in our case, it is. All right. What about weight? What kind of variable is that? Numeric. And age? Also numeric. Okay. So you already have an intuitive sense of what is a categorical and numeric variable. I didn't even have to tell you. You just figured that out on your own. But let me just put kind of a formal definition of a categorical variable. Okay, so categorical variables tell us what type or what kind. So if we ask, what is your hair color? That would be a categorical variable. Some will say the name is a categorical variable. Other people will say the name is an identifier. It's a trivial point. We generally don't do too much analysis on the name variable or anything that could act as an identifier. So categorical variables tell us what type or what kind. Numeric variables tell us how much or how many, okay, with a number. So the weight variable is numeric because it tells us how much does someone weigh. Age is how many years has this person been alive? sometimes numeric variables can become categorical variables. So maybe age can become categorical. We'll say, so if you go to a bar, they don't actually care about your age. They don't care if you are 25 or 30 or 60 or whatever. They just care what? Are you over 21 or are you under 21? Okay. They have turned your age into a categorical variable. Are you old enough to legally drink or are you not? Okay. At least in the United States. So if you are 21 or older, you are categorized as legally allowed to drink. If you are under 21, you are categorized as not allowed to drink. The underlying variable is numeric. We want to know how long have you been alive, but we've turned it into category by some line. All right. So let's see. We'll ask a question and you will tell me if this variable is numeric or categorical. Okay, someone's height. Numeric, okay? And how would we record someone's height? What kind of units would we use? Yeah, probably in inches or centimeters. Okay. Depends where you live, right? Okay. But in some unit of length, all right? All right, someone's race. Categorical, okay? And we would record that with some kind of categories, all right? On the most recent census, there was, I forget how many, several options for what race you could choose, okay? A long time ago, at least in the United States, there were really only two categories, if you were white or not. That was today. In modern census, there are, I think about a dozen. No, that's it. There's ethnicity has a lot, race has not as many, but still a lot more than two. Okay. What about someone's zip code? Zip code is categorical. Okay? It is not a numeric variable, even though it's a number. Okay? Your zip code might be 90025, but it does not tell you how much or how many. It just puts you in tells us your location. It tells us what type or what kind, I guess, the category of where you live. So that would be a categorical variable. Same with area code. Right? It does not make sense to compare zip codes or area codes and say, I have 200 more zip code than you. Okay? Whereas with weight, we can do that. I have 30 more pounds than you, or I have 5 more years of age than you. That you can say. If you cannot say that with a variable, it's probably not numeric. Okay. On the other hand, we can turn categorical variables into numeric variables. Okay. Generally, we will turn this into a 0 or 1 variable. Okay. So this might be called coding a categorical variable into a numeric variable. So we can record sex as male or female. We could equivalently say add a category or a column called is male, and in that case we would say Adam is male, so we put a 1 there. Betty is not male, So we give her 0, Claire gets a 0. Okay. Yes?
Consider it's coding?
Yeah, what the process is called coding. That doesn't matter as much as if you were to see data represented this way, can you understand that this is the equivalent data? That's the important part. The word, not as critical. Okay. Does that make sense? Going from the categorical to this, and then switching back? Okay. All right. Okay. The book in chapter 1 goes into a little bit more detail about how data might be recorded. It talks about stacked data versus unstacked data. I think the concept is simple enough for me to allow you guys to do the reading and figure it out on your own. But again, if you have any questions, feel free to post your questions to the Facebook group and ask there. So if we have data recorded, like so. So with 3 people, it's simple, but you can imagine I've collected maybe data from 1,000 people. So my case table would have 1,000 records in it, 1,000 rows, 1 row for each person. It might be complicated to see all of this data. It might just be too much information for us to really care. So we might summarize our data, okay? Summarizing data. So one way is we can summarize categorical data. And we would summarize categorical data with what? A frequency table. And the way a frequency table works is you'd have the category, and the frequency. So, which variable is categorical in our data table over there? Sex, okay? And what are the categories that exist for the sex variable? Male and female. Okay. How many males appear in our data? 1. How many females appear? 2. Okay. So this is my frequency table for our very simple data table. Okay. So this might be overly simplistic, but I hope you guys can understand this. And you could imagine doing such a thing for a larger data table. You could count by hand, or you could ask the computer to summarize it for you, and you'd have this frequency. We might have something called a relative frequency. So frequency gives us the count of each category. Relative frequency would give us a percentage. Okay? So how many people total do we have in the table? 3 people. So what percentage of our data is male?
0.33.
Okay, so the fraction or proportion would be 0.33, or a percentage would be 33.3%. So either form is acceptable. And is there any question on how I got 33.3%? How did I do this? I did 1 divided by 3 gives me 33.3%. And so 2 divided by 3 would give me 66.7 if I round. Total of 100%. So this would be relative frequency. Shouldn't have to write this, but I would say 1 divided by 3 equals 0.333, which is equal so that should be quick for you guys. Okay, before we get more into this, let me take a small detour on how we should collect our data. So like I said in the beginning, when we gather data, we are not observing a population, but we are observing a sample. Okay. So the sample that we observe has a limited size, okay? So the sample size is equal to the variable n. So what is n for our data here? Data table. So how many people did I interview into this data table? 3. So my sample size in this case is 3. I have interviewed 3 people. The amount of data I have collected comes from 3 people, so my sample size in this case is n equals 3. Okay. The sample size is n, or sample size is the number of cases Our data can be gathered either through an observational study or through an experiment. In an observational study, we just observe. just observe, or we try just to observe our subjects. Ideally, we do not interfere with these people at all. Okay, that's an observational study. And on the other hand, in an experiment, we try to control as many aspects of variation as possible, with the exception of what we call the treatment. Okay, I know in that definition for experiment, there's kind of this a lot of mumbo jumbo in there. This is the key difference. In an ideal case, in an observational study, we have our people to study, and we observe them, okay? And we study what they do, and we record information about them. In an experiment, we study people, but we try to say, we try to control things that happen, right? So let's say we wanted to know what will help people lose weight, okay? So we want to know, if someone wants to lose weight, is it better off if they exercise? Is it better off if they control what they eat? Is it better off if they take these drugs? What's going to help people lose weight? Let's say that's the question we want to go for. In an observational study, maybe we ask for some volunteers. We get 100 people to volunteer. And then we just study what they do. Okay? Some people are going to exercise, some people are going to diet, some people are going to do this and that, and then we see how much weight they lose. On the other hand, with an experiment, we would ask people to sign up for our experiment. And we would say, thank you for signing up. Starting tomorrow, you guys are going to exercise, and this is the type of food you're going to eat. Over here, you guys are not going to exercise, but this is the type of food you're going to eat. And we will set up different groups, all right? Because the truth is, what affects weight loss? A lot of things. A lot of things in life will affect how much weight you lose, okay? The food you eat, you know, your activity, your stress, all sorts of things, okay, can affect how much weight you lose. So, in an experiment, ideally, we could control almost all aspects of your life. If we had full control, we would say, you know, every single person in this experiment, starting tomorrow, is going to wake up at 8 a.m. and they are going. The first thing they're going to do is do this, and the second thing they're going to do is do this, and the third thing they're going to do is do this, and everybody's going to eat the exact same food, and everybody's going to do the exact same activity, and we can see what happens. And we can say, this group has done every single thing exactly the same as this group, except over here we made them run 3 miles, and over here we did not. Everything else about these people's lives are exactly the same, except for the running. And if at the end of the experiment we see that this group that did the running lost extra weight, we can say the reason why this group lost the extra weight is because of the running. Because everything else about their lives were exactly the same. Right? In an observational study, we don't do that. We let people live their lives, and then we just see what happens, and then maybe we find out that people who ran lost weight compared to those who didn't, but we don't know if that's the reason why they lost weight, because there's all sorts of other things going on. Okay? Maybe those who ran also chose to eat healthier. We don't know, all right? Because there's all sorts of things happening. So in an observational study, we can't draw cause and effect conclusions. Whereas from an experiment, we can. Yes?
So you would say an experiment is more accurate? And so,
Accurate is, I don't know if it is the right word, but,
precise?
but an experiment will be able to answer a question of, did this cause this? Whereas an observational study cannot answer that question. Okay? So, from a well-designed experiment, and if the data supports it, we can draw a cause and effect conclusion from an experiment. You cannot draw a cause and effect conclusion from an observational study. But sometimes experiments are not possible, or they're not ethical. Let's say we wanted to know, does smoking cause cancer, cause lung cancer? Okay. Well, if we what would you have to do to answer that question?
Case studies.
Okay, so case study, but is that an observational study or is that an experiment? Yeah, if you want to know, does smoking cause lung cancer, the only real way to do it would be to say, please participate in my study. Thank you for volunteering. And starting tomorrow, this half of you are going to start smoking a pack of cigarettes for every single day for the next 20 years, and we will see if you develop lung cancer. And you, the other half of you, you are not to go anywhere near a cigarette at all for the next 25 years, and we will see how many of you develop lung cancer. Come back to me in 25 years, and let's see what happens. Okay? And then, if we find out that these people and then we would also, ideally, we would control every single thing else about their lives. And then, at the end, we see, 70% of this group developed lung cancer, and 2% of this group developed lung cancer. Then we could say, well, everything about these people's lives were exactly the same, except for these guys smoked a pack of cigarettes every single day, and these people did not. Therefore, we're pretty sure smoking causes lung cancer. But that would not be an ethical experiment, okay? So, well, you could never do an experiment like that, so with an observational, all we could do were observational studies and say, okay, well, we followed these 1,000 people. Some people smoked, some people didn't. We found that the people who smoked developed lung cancer at a higher rate. But does that necessarily mean that smoking causes lung cancer? No, it's a difficult question to answer because the argument that the tobacco industry made for a long time, they now admit that smoking causes lung cancer. But for the longest time, they would say that those people who developed lung cancer, there was something in their genetics that was going to cause them to develop lung cancer, whether they smoked or not. Okay? And it was the same thing in their genetics that caused them to seek something out that soothed their lungs, and that's why they picked up smoking. Okay? It sounds like a crazy argument, but if you hear them out, you'd be like, oh, well, I can't really refute that, right? It sounds far-fetched now, but it's difficult to disprove that until you do an experiment, okay? So an observational study, you cannot draw a cause and effect conclusion. Here's another example where you cannot draw a cause and effect conclusion from an observational study. This was a real study done, and they wanted to know what things might improve, early childhood education levels. Okay, so these researchers, they went to thousands of families across the United States, and they looked at the children and evaluated how well do these children read. Okay. And what they found was that different families, some children read at grade level, some children read above grade level, other children read below grade level, and other children were way behind. So they had a wide range of abilities for reading. And they looked at all of these other variables of interest that they collected, and interestingly enough, one thing that correlated, meaning that was strongly tied with reading level, was the number of appliances in the house. Okay, so they found that houses that had lots of appliances, being like dishwasher, refrigerator, washing machine, houses that had a lot of these things, the children tended to read above grade level, or at least at grade level. And houses where there were not a lot of appliances, they did not read as well. So, what can we conclude from that? Does that mean one way to solve our education problems in America would be to provide dishwashers and washing machines and blenders and things of that nature to people? Would that solve our problem? No. That would be drawing a poor cause and effect conclusion from an observational study. What do you think is actually going on there? It's a class and wealth issue, okay? And we still don't, and even then, so it turns out that families with more money tend to have children that read better than families with lower income or less money. Does that mean money will solve the education problem? No, there's something very complicated that we don't fully understand that relates income to education or just reading level and things of that nature. But it would still be incorrect to conclude that just throwing money is going to solve problems, okay? They're highly associated. There's a strong association between income and education level and reading and things like that. But but we don't fully understand the cause and effect nature of it. Okay. So, in summary, yeah, you can't draw cause and effect conclusions from observational studies, but you can draw them from an experiment. There is more detail in your book as you read this week, so please be sure you do your reading. Questions? Let me check the time here. Okay, why don't we take a short break here? Let's take about a 10-minute break.